Pi-hole is a network-level add and tracking blocking application, which you can optionally also use as a DHCP server. The way we'll use Pi-hole here is we'll first set up a DNS server that Pi-hole will actually use to resolve requests, a so-called upstream DNS server, and then we'll add a DNS section to our WireGuard config. That means that when we are connected with WireGuard, our DNS server will be Pi-hole, which will block all known ad-related domains by resolving them to 0.0.0.0, while all other legit requests will be resolved normally using the upstream DNS server. In Linode console, add an A record. I'll be using pi-hole.do-p.com and then the public IP of my VPS, and set the TTL and click Save. As usual, let's first create the necessary directories for this role, and then let's open main.yml inside tasks subdirectory. We first make sure that the directory named services exists, and then we copy the Pi-hole directory to it. This one is a bit tricky, so bear with me. I need to make sure that the directory named etc Pi-hole with this owner and this group exists. I'll use this directory later as a Docker volume, but in order for Pi-hole to be able to use it, you must set these permissions. These 999s are user ID and group ID of the user named Pi-hole, which is the default user for the official Pi-hole Docker image. That user will try to write something to this directory, and unless you set these permissions, that operation will fail. Then we run Pi-hole with the help of Docker Compose, and finally we'll add a backup script to the root's cron tab. In case you're wondering why we didn't have this backup script for traffic, there's no need. The only data that is produced by traffic is recorded in acme.json, and if that file is gone for whatever reason, it will be recreated by traffic. Save the file and open dockercompose.yml inside Pi-hole directory. We have services at the top level, and this time it's Pi-hole. We'll set the container name, host name, Docker image and image tag, and we'll instruct Docker to restart this container unless explicitly stopped. Pi-hole is also a part of a Docker network named web, and then I'm mapping all DNS related ports, but I'm doing it in such a way that they are reachable only through that additional loopback address we added previously, because I don't want that Pi-hole can be accessed publicly. As for volumes, I want to preserve data in etc Pi-hole and etc dnsmask.d directories as noted in their documentation, but I'm also adding a custom etc hosts file. Let's jump to the drawing for an explanation on why we need this. If your Pi-hole hostname is set to the same entry you are using for DNS, and in my case both are pi-hole.do-p.com, you will need a custom etc hosts file mounted as a Docker volume. The reason is that if you don't provide etc hosts yourself, Pi-hole will create its own etc hosts inside the container, and it will add an entry for its own hostname, pi-hole.do-p.com, but it will point to a Docker container IP, which of course is in a private subnet. So when you try to resolve pi-hole.do-p.com using Pi-hole as your DNS, Pi-hole won't ask the upstream DNS server to resolve this. It will instead return a local IP address of the Docker container because it has it in the etc hosts file, which is the first place to check for the host's IP. To avoid that, we'll supply a custom etc hosts file which has a public IP for pi-hole.do-p.com, essentially returning the same IP address as if it was resolved using the upstream name server. The reason we are doing all this is because we want to access Pi-hole through traffic, utilizing HTTPS and IP whitelist middleware, but for that to work, we must come over the public IP address. I'm then setting environment variables, and you should check the Pi-hole Docker deployment for details and additional variables that are available to you. I'm then adding some logging parameters and then labels. I'm telling traffic that I do want it to monitor labels for this container. I'm setting a Docker network where this container will be reachable, then a host rule, a TLS resolver, an entry point, and then a port where web server inside Pi-hole container will listen on. And finally, I'm setting an IP whitelist middleware. Save the file and then open the .env file also in Pi-hole directory. These are pretty self-explanatory. Loopback IP is an important one. And for Pi-hole DNS, you might want to use some other servers, but this can be configured later through the web UI. I'm setting the password for the web UI, email addresses, service name traffic will use for this container, IP whitelist subnet, and some variables for the backup script. Save this file too and open etc hosts file. Last line is the important one. We want Pi-hole to return a public IP of pi-hole.do-p.com, not the private address of the Docker container. Save the file and now open backup.sh also in Pi-hole directory. This one is very similar to the backup script for the LXC, difference being that I'm doing docker compose down instead of stopping the Linux container, and then docker compose up-d. This script will also delete some older backups and it will write results to the database. Save the file, open setup.yml, add Pi-hole role and comment out everything else, save the file, and in virtual environment run Ansible playbook. Ansible has finished. There's now a new entry in the traffic's dashboard. And if I go to the pi-hole.do-p.com while connected with WireGuard, I'll see Pi-hole's dashboard. I can log in with the password I've set in the .env file, and then I'll have access to all settings. Now, I'm not going to go through all of these, but I'll point out that you can whitelist or blacklist domains, that you can create local DNS entries, and that you can configure DNS servers in settings DNS. I have Cloudflare servers, which I configure through the .env file. In terminal, if I try to resolve e.g. metrics.icloud.com, I'll see all these IP addresses, because it was resolved using my current DNS server, which is Cloudflare. But if I do the same thing with specifying VPS additional loopback address as resolver, Pi-hole will intercept this request and it will resolve it to 0.0.0.0, which means that this host won't be reachable. That will happen for all domains related to ads and tracking, and a list of those domains is maintained by the Pi-hole community. To make this behavior the default one, I'll edit my WireGuard config and add a line in interface section, DNS equals, and then the additional loopback address of the VPS, meaning that while I'm connected to this WireGuard endpoint, use this IP as my DNS resolver. I can now try this without specifying the server, and it will still resolve it to 0.0.0.0 because I am connected to the VPS with WireGuard, which means that my DNS server is now Pi-hole. What you can do now is edit WireGuard config on all clients you have, add DNS line in interface section, and you can still use your favorite DNS server for legit requests, but domains for ads and tracking would be intercepted by Pi-hole. A quick recap regarding Pi-hole. We deployed it inside a Docker container with all appropriate labels so that traffic can add all necessary settings. And we mapped all DNS related ports, but using the VPS additional loopback address. That way, only those inside this private network can send queries. We don't want random people on the internet spamming our DNS server. Because we are connected with WireGuard and we have the additional loopback address in WireGuard's allowed IPs, meaning it's added to the route list, we are able to send queries to this address. Those queries first reach the VPS, but are then routed to the Pi-hole container because Docker has added the necessary rules to the IP tables. If I list the rules for the NAT table, you will see these three additional rules, which says that any network packet that has this additional loopback address for its destination and these ports will be routed to the Pi-hole container. Note that Docker hasn't created an IP tables rule for port 80 I defined here using Docker labels, because HTTP will go through traffic. When you try to access the Pi-hole dashboard, you will reach port 443, not 80, because of the redirect to the HTTPS we configured in traffic. That request will then be routed to the traffic container, and from there, traffic will communicate directly with the web server inside the Pi-hole container because it knows its IP, and we told it that the web server inside the container is listening on port 80.